Let's get going. So this is the July 23rd, 2026 Crossplane community meeting. Let me go ahead and drop a link into the Zoom chat so folks can, where is that window? There it is. So folks can go directly to the agenda document and add any topics they may want. So folks have that now. All right, so the first thing we want to talk about is patch releases. These are the releases that we've done since the last community meeting. These were actually done just today, so these are fresh off the presses here. So all of these supported versions, which is the last three minors, 2.3, 2.2, 2.1, and then 1.20 is the last, v.1, which is still supported as well for the time being. So let's take a quick look at what actually was went into this patch release here. So a number of security CVE fixes and such for our dependencies. As always, there's always a ton of those every week, basically, it feels like. But then there's a couple other important fixes to mention here. So one is that it was reported from the community, I think an issue that's been there for a long time, because we backported this to all supported versions. But if you're using usages, when the controller is trying to add the using object as an owner reference to that usage, it would end up continuously trying to do that because it wouldn't recognize it was already there, and it would try to do it again, which would cause like a watch event, and then the reconciler to run again, etc. So you would basically hit the XR circuit breaker on this. In 1.20, there is no circuit breaker, so I think that would be even worse there. Where you're basically going to have a continuous reconciliations and using resources that you should be using. So that is fixed in all supported versions, and I think a rather important fix because of that performance impact there. And then another important thing to note too is that for I think 2.3 and 2.2, since we moved to Nix as our build system, the images that we produced did not have the full set of dependencies and dependency information embedded in the images. So scanning tools could not properly run over them to look for vulnerabilities. So we fixed that in all versions that we're building with Nix, so that released container images now should be scannable again for anybody using any scanning tools like Gripe and whatnot. To check for vulnerability. So that's now been fixed as well. I think those are the two most important fixes to mention here. So thanks Lovro for driving those patch releases and getting those out today. Yeah, and those are the important fixes we mentioned. So then so those patch releases for recently released and supported versions of Crossplane. Now we're also working on 2.4, of course, which is coming up sooner than later. I think before the next or right around the next community meeting, we should have 2.4 out. So if we briefly look at the schedule here, what it looks like as it stands right now is that in just about 2 weeks, we'll have feature freeze. So we want to get all features in and merged for 2.4 that we're planning on doing. And then the week after that, we'll do code freeze. And then August 18th is what we're expecting for release day. These dates are always, a bit flexible. They'll be quality driven and not date driven. So these may move around a bit, but this is what we expect right now with the regular cadence and the way the milestone's been going so far. So as we're getting closer to feature freeze and then code freeze, I would definitely request folks for any PRs that are important, that community wants to get merged in, we wanted to get eyes on, etc. Now's the time to do that before we hit feature freeze and code freeze, and then not accept more changes for the release. So if folks have important PRs they want to call out, please do reach out, mention it here, mention it in Slack, whatever you want to do. So that we can get things in that people actually care about. Let's see. All right, so we've talked about these items here that we're planning on in the 2.4 release. Most of these are merged already. This is merged. This is merged. I think we've gotten rounds of feedback on this one, so we expect that one to get merged. I talked to Chris just this morning. So a lot of those are going to be included for sure. Adam, we had multi-active function revisions on this list for a while, and I know you're kind of just getting back ramped up on that now. So what's your take on that one?
I would like to get it into 2.4 if we can, just because I know it's something that a lot of users are waiting for, and especially people who are using the new DevX, it's going to be yeah, I think an important one for them. Kind of becomes more important the more logic you're embedding into your functions, right? Um, so I that said, I mean, I think I don't want to rush it either. So if there are concerns that anybody has on the design, or if it uh, takes some time to get the actual code changes in, then it can slip. But if we can get it into 2.4, I think that would be great. And I did share. I think I put a link in the PR here and also on Slack a POC of the design that's described here. There's a couple discrepancies between the POC and the design, but nothing big, just naming and stuff. Um, so that POC I think is close to being like PR ready. Needs a few adjustments and probably some tests, but I do think if we're happy with the design, I can get this into shape pretty quickly.
Awesome. Okay, yeah. So definitely a lot of progress in the last week you've been working on this, Adam. So great to see that. Yeah, and then I agree with the sentiment that it's definitely a nice feature we would like to have included in 2.4, but if there's feedback or concerns on it, then we're not going to rush and put it in if it's not ready. Okay, sounds good. And is Bob here today? I don't think I saw Bob join. I wanted to ask him about the management policy options stuff. I can follow up with him now. Yeah, okay, sweet. So yes, please do, folks, reach out if there's PRs you want to nudge along the way, because we've got 11 of them in review. And they're not all getting the same amount of progress on them. So feel free to nudge anytime, reach out directly if you want to find some help with one. I'm always open for people pinging directly. So please do if you want to. All right, let's keep rolling here. Let's see. Let's go to the ecosystem stuff here. As always, a bunch of releases. Jesus, is there anything you want to talk about for you have a bunch of providers and releases and stuff. Anyone you want to call out with all the work you've done, dude?
Uh, Nothing in particular. I guess, well, I have something still like half cooked because I was pretty much in a rush to release ClickHouse one. And we used it. But I released it with a critical bug, I would say, that we cannot import resources anymore. And I'm about to send a pull request, so I guess
Nice.
hopefully today, tomorrow we will have it fixed. Nobody will notice. I don't know if there are people using it. We are using it in production, and we just realized because we could not import resources anymore. Yeah, it's
Nice. So that's good validation of production usage. That's definitely good. It's going to be working, or if it's not,
it's
it'll get
hard.
fixed.
For the DBOps, we have the same issue, but hopefully we can add the end-to-end test. So basically, we spin up a ClickHouse service in a kind cluster which will run the chainsaw test, and we saw where the error was there, and then we replicated the same fix for the ClickHouse. But yeah,
Awesome.
really soon.
Cool. Yeah. Well, once again, as always, thanks for all the provider ecosystem work you're putting in and all the providers you're releasing and stuff. That's great for the ecosystem as a whole.
Yep. Thank you.
All right. Then Sergen, is there any some of the investment section here for for upjets and ecosystem and extensions and stuff like that? Is there anything that you want to call out here besides what you'll be talking about later in the agenda?
Yeah, so maybe quickly say a few things on them. So there is an open PR in the template repository for adding new agentic skills to help our provider implementation, like resource addition and some reviews of these editions. This is still in progress. We are still, Jonas is working on this, and he is also, as far as I know, actively using in his work to add something. And it's a progress to see what is doing the agent and what can be the improvement points. So I think this is the word to call in here. And another items are mainly, the update improvements, especially for the integration to new underlying provider change and also increasing our consistency in the direct mapping with the underlying providers level. So these two items, and also some provider specific works I put to here, because especially the last item for adding the provider metrics for Azure AD, and GCP is important, because we have just for the big for providers, we have just for the AWS one for the provider metrics. I mean the cloud metrics for collecting, let's say, the returns from directed cloud providers. So now the Jonas also added the Azure and Azure AD, and for the GCP, the PR is in review, and we are planning to include this for the next release. So these are our current, the most important, I think, the investments for the Upshet and ecosystem.
Awesome, Sergen. That sounds good. Thanks for those updates. And then a quick question. So the agentic skills here that we looked at. So those are going into the Upjet template repo, which is like the base starting point for any new Upjet based provider. Is that right? So if people generate new providers, they would basically have these skills that are general for any Upjet based provider.
Yep, that's right. So the idea is helping to people for during the first steps, like bootstrapping and adding new resources and validation stuff.
Oh, very cool. That sounds awesome. Cool. Okay. Anything else to add for folks for ecosystem functions, providers, configurations, etc.?
Yeah, there's something I almost forgot.
Yeah.
It's about functions and how to interact with them. If let's say third-party applications, let me explain you briefly what I try to do. I was trying to use Crossplane diff with one of our compositions. The problem is that we have a kind of morbid XR with thousands of managed resources on it, and that's not fitting the gRPC max. Default, I think, is 4 megabytes or something like that. So we have to go function by function, telling, okay, the maximum is like 6 or 8. With Crossplane diff, there is no easy way to do that. And one way I found it is, okay, we can use this Docker runtime and something like that, an annotation to tell it, okay, this is the TTL for you. And I did a pull request for a function go templating and got accepted, and then I realized that probably, and this is the question, we should benefit, maybe we benefit about having, let's say, standard environment variable names, similar as we have for the TLS certificates there, to have the same for TTL and some others that are like common for all the functions, or should be common for all the functions. The problem is that where to, let's say, contribute on that if in the both function templates go on Python probably, or going one by one, if that makes sense. That's the first point.
Yeah, I think in general, having a standard flag environment variable configuration option that's like consistent across all the functions for exposing the max message size or received message size, I think it is. That definitely makes sense to me. And I have you seen so far that the functions that do expose it, have you seen if that there is any inconsistency across those, or so far the ones that implement it are consistent?
I think none of them are exposing the environment variable. All of them are exposing the
they all flags.
The flag. Yeah.
Oh, I see what you. Yes.
So the problem is that with Crossplane diff, there is only one way, as far as I know, to inject that value, and that value is environment variable. So I started with code templating, then I moved to auto ready, and I realized, oh, we're gonna have like inconsistency, because also the tool is gonna suffer if we have to go, okay, if the function name is this, you have to use this environment variable.
Yeah. So to me, and Adam, maybe you have, and Stephen, I know you kind of were the first person driving exposing that as a configuration option for functions. So to me, it sounds like a good goal to, yes, like environment variable, so there's more flexibility in how it could be exposed as a configuration option is good, and then consistency across all of them is good as well. I don't immediately have an idea of like, hey, what's the cheap way to put it in one place and everybody gets it? That I don't have maybe there's a smart, innovative way to do that I don't know, but I am in support of consistently exposing it across, starting in the template repos, so that new functions get it for for free when they get started and bootstrapped. But then adding it environment variable support for those flags to the existing repo functions. Like I'm all in support of all that as well. And Adam and Steven, do you have more ideas than that?
No, I'm trying to think if it's something we can do at the SDK level, but I think it gets set in the main, right? So like that isn't part of the SDK. But I'll think about that. It is, yeah, it definitely would be nice to have it everywhere.
Yeah. And either way, Jesus, your idea is supported, my friend. So if you do more work to expose it,
Okay.
or yes, well, that should get approved, and that we should help out with that for sure, dude.
Okay, thank you.
No pushback.
And I think also like anything we can do in the Crossplane diff isn't part of the core CLI at this point, but anything we can do in the CLI or in Crossplane diff to make it easier to set that, so that people aren't like digging through files and working around and having to edit annotations. I think open to ideas there.
All right, great, good question. And yeah, and then always reach out for any support we can provide. All right, let's move to next topic, next set of topics then. So there's a couple of links here for articles and posts and stuff about Crossplane. So always dig into those as you wish. Quick updates about KubeCon for Salt Lake City in November, I guess it is this year, which is coming faster than I expected it. So we got good news yesterday that we basically are we have submitted applications to take advantage of every possible benefit we get as a CNCF project. And we've got good news for all the news we've got so far has been positive. So the maintainer track talk was accepted. Our Contrib Fest session with Yuri that Yuri is driving. Thank you, Yuri, for that. That was accepted. The lightning talk that Mitch Davis is driving was accepted. The keynote video on like a video playing in the keynotes was accepted as well. Victor will be driving that. So the only one we haven't heard of is the booth in the Project Pavilion, but I would be surprised if that was not accepted. We tend to, I'll knock on wood, but I don't think we've ever been rejected from that.
And Jared, how does it look for graduated project? Is it like all 3 days kiosk?
You're full time, my dude.
Yeah, full time. Oh wow.
Yeah, we did that in Amsterdam. We were full time in Amsterdam. So that's why it's even more beneficial for folks, on this call, folks in the Crossplane community. Like, if anybody who wants to come hang out there, answer questions, meet with the other people that are learning about Crossplane, that's always super, super helpful. Because we're there we have a booth there the whole day. So any people want to come by for at least even an hour to come and hang out and chat and meet people and talk, that's always super helpful. So we appreciate that. But yeah, so I'll share any news that we learned there, but everything has been, we're 5 for 5 so far, I think, or 4 for 4, or whatever. So things are looking good so far for Crossplane in Salt Lake City. All right, Adam, can you give us some quick updates about SIG-CLI?
Yeah, there's a couple of fixes that have been merged and backported into 2.4, and so I think we're actually a little bit overdue for a patch release there to fix a couple of these. So I'll try to get that out either this week or early next week. Beyond that, I think there's not a ton of stuff merged yet for 2.5, but definitely a few things in the pipeline, some nice code generation improvements, TypeScript support, which I don't know if Steven's on the call, but I'm not sure how much time he's had to dedicate to that, but would be, I think, nice to get in. And then the simulation stuff that Chris is working on, which will be, I think, a big feature, really nice addition. So yeah, a few things that we're tracking for 2.5. And I guess just to remind everyone, the CLI version numbers have diverged from core version numbers now. So CLI 2.4 is the existing stable release for CLI. We do continue to backport stuff to 2.3, so we can cut matching CLI releases for the core in 2.3, but we won't do that past 2.4. We're going to diverge the version numbers.
And both Eric and Steven are on the call here, so we can directly thank you for the efforts that you're driving. So we appreciate that, guys. Chris is not, but he knows he is also appreciated.
Yep.
If he doesn't, I would be shocked. He knows we love him. And then John mentioned in the chat that the 2.3.4 stable build broke Crossplane diff. So we're trying to get a fix out for that today. Is that from like the XR, the UIDs, existing XR UID thing fix, John? Is that what that is?
Yeah, I had hard baked a
shoot.
workaround for that problem into diff, and so the workaround broke when you fix it.
Got it. Well, I definitely appreciate you being on top of it already to fix that and have a workaround in place before that. So your maintainership is also appreciated as the appreciation party continues to roll on, John. All right. Cool. What's next? Okay, so here's another topic here, and then we'll get into our guest speakers today. But they're not really guests because they've been part of the project for a long time, and we appreciate them too. So I just wanted to call out this. So 2.3, the Crossplane 2.3 release. If you look at the release notes, I think I'm linking to it actually. We made a refactor of some types, the core and runtime types that for managed resources and whatnot. That refactor was necessary so that we could move the Crossplane CLI out of the core Crossplane tree and give it its own repo and have its own release schedule and all that sort of stuff. So it was a necessary refactor and a complicated one as well because of circular dependencies between Crossplane runtime, Crossplane APIs, Crossplane core, etc. So Adam worked through all that and got to a end state that enables more tools to be built outside of core Crossplane and have access to the APIs and important types and such. So that was good, but we did not immediately follow up on the provider support of. So, for instance, Crossplane Tools is a code gen repo that most all providers use, basically, and it will generate the important method sets that all managed resources in Crossplane need to support in order for the Crossplane Managed Reconciler to recognize that they are a Crossplane managed resource. So we didn't immediately fix that. And a wonderful community member went and started updating the Crossplane tools to use the new types and generate the new types and make providers and their code generation compatible with Crossplane 2.3 and beyond. So we've got a little guide here that provider authors can use. If you're a provider consumer, you don't have to worry about this at all. But if you author or maintain a provider, we wrote a little guide here that shows how to basically update your source code of your provider to be compatible with 2.3. So, you need to update some import statements. You need to change a couple of types, change the name of a couple of types, and then rerun, generate, and go mod tidy and stuff like that. And that's about it. So it's not super complicated. It was difficult to reason through, but now that we've got an end state here and a clear guide, it's not that hard. And then I think Alper and team are running through or supporting a PR to also do the same thing for upjet providers and upjet template and stuff like that. We've done it for the classic native providers already. That one's done, and that provider template is updated, but upjet will be updated soon as well. Yes, John, I like your suggestion in the chat, but yeah, for renaming Angry Jet to Exhausted Jet. It's one thing that's actually kind of funny about that too is that Angry Jet goes forgotten about for a while until it needs to be updated or something breaks with it. It can go months or maybe a couple of years actually with nothing being changed at all, and then oh wait, shoot, something needs to be updated there, and it's been running the whole time and generating method sets and everything for years and providers, and often an unsung hero, but it's probably tired by now. Sleepy Jet, there you go, boom. All right, so that's it for me. I will be quiet now, and I will turn the meeting over to our esteemed community co-workers, Sergen and Alper, to talk about an important topic with API lifecycle versioning and whatnot. A difficult one too. Teach us, boys, teach us.
Thank you, Jared. So let me quickly share my screen so to show you the presentation what we did in the KCD Istanbul. So we did this presentation together with Alper the last weeks on the KCD Istanbul. So this is pointing to the conversion framework, what we did in there, and what are the challenges and what we learned here. So there are a few cross-plane information. I think there is no need to hear repeating here, as all of them are already, as you know, this all tools. So maybe just capturing here, and I will give the word to Alper to continue the core framework to mention. So as you know, especially for the object-based providers, we have lots of CRDs. Just for the big providers, we are more than the 2000. So this is actually the conversion is not directly the problems itself. The scale is the problem. So, and the idea of this, also the presentation on showing this, what are the challenges on this scale. So Alper, would you like to continue on after the short actually enters to the words, and maybe mention about the core framework?
Yeah, thank you very much, Sergen. So I tend to talk too much. I try to keep it, short and concise. So as Sergen mentioned, the Kubernetes ecosystem already has some tooling and also a mature framework, for API evolution. So when you look at these two API shapes, V1 Beta 1 and V1 Beta 2 versions, you see that an HTTP backend with a service name and service code has been transformed into an embedded object, right? Service becomes an embedded object, and then we have a name and then a port object with a number where you can specify the endpoint's address. So handling something like that is pretty simple, and we already have the tooling. But what are we doing on top of it, right? When we are talking about thousands of CRDs, like 2,000 generated APIs, as Sergen showed in the previous slide, it's no longer a simple translation problem. We need to consider this as an engineering and systems problem where we can handle such conversions for those generated APIs. And we shouldn't also forget that we don't control these APIs, right? So Object generates these APIs based on the Terraform resources, and this means that most of the time the API changes we need to handle are out of our control. So APIs evolve, it's a reality, right? So custom resource definitions are contracts. So we need to be careful when, changing the shape of these APIs, because clients of these custom resource definitions, like, creating, updating, and deleting, etc., the custom resources, we should be careful not to break them. To complicate things, as you all know, multiple versions coexist in a custom resource definitions with different shapes. But the important thing is they are representations of the same underlying object. So they are different shapes for the same object. And when you make mistakes, you need to be careful, because in a good case, like, you will make an request to the API server and it will be rejected. But even worse, like, it may result in a configuration change or a missing configuration, and that may result in your infrastructure changes, unwanted infrastructure changes. You can switch to the next slide. Thank you. So in a CRD, APIs are versioned, and as we discussed, when we bump, for example, the underlying Terraform provider, it may result in breaking changes in our CRDs. And all of these versions of a CRD are basically representations of the same underlying object, meaning that, we should be able to round trip between different versions without any loss. We can switch the slide. So, so in this diagram, what you see here is you see the same cube around the triangle, a circle, and a square, right? So these represent different shapes, meaning different APIs, but the underlying object is always stays the same, is the same object. Now we can switch the slide. So one way to solve this problem is to have conversion between each pair. And for example, we have 5 versions, and then we could be converting between each of these versions, from V1 to V2 and from V2 to V1. That's a directed graph. And you would end up with n times n minus 1 conversion functions, right? So, and n here denotes the number of CRD versions that you have. But there's a better way to do this, right? Instead of, growing this quadratically, there's a better approach to this. Can we change this slide? What we do with Kubernetes APIs is, we do this conversions on a different topology. On the start topology, where, the central node is called the hub, and then we have the spokes. In this specific example, we assume that the hub is V1, and the spokes are V2, V3, V4, and V5. And instead of writing conversion functions across all possible pairs, right, we do this in a at most two hop topology. Meaning that if you'd like to convert from V2 to V3, you pass through V1. And when we do this, the number of conversion functions that we need becomes a linear function of the number of versions, right? We can switch the slide. And here you see an example how this goes in the API server. So we have the notion of a hub, the central in the topology that we have shown before. We have storage versions. This is the version stored in etcd. And we are in the context of Object and its configuration framework. We also have the notion of a controller client version. But this is basically the version that's used by the reconcilers. So let's assume this user, makes a request to the Kube API server for V1 Beta 2. This is the version requested by the user. And the storage version in this case is V1 Beta 1. And in order to complicate the example or, to give the full example, we assume that the hub version is V1 Beta 3. So when the user makes a request for the resource in version V1 Beta 2, API server needs to fetch that resource in version V1 Beta 1 as its storage version. And it checks that and sees that the request, it needs to convert it to V1 Beta 2, but it needs to do this in two hops, passing through the hub versions. So it needs to first make it convert from V1 Beta 1 to V1 Beta 3, and then from V1 Beta 3 to V1 Beta 2, and then it can serve the client's request. Next slide, please. So now we are looking at what object generates for the hub and also for the spoke, right? So the managed resource that object generates, the managed resources that object generates needs to satisfy these, conversion.up and conversion.convertible interfaces from controller runtime. But if you look at this, it just calls a round trip function, which is part of Object's API conversion framework. And, it's always, the generated code is always like this. This looks boring, right? The important thing here is we dynamically prepare a conversion registry that handles the specific conversion. So Object always generates this code against what we call as a conversion registry. And the provider dynamically configures that conversion registry to be able to convert between different versions of a managed resource. So now we will start talking about Object's API conversion library. The central interface is, in our framework, is the conversion interface, a simple one. It just, takes two runtime objects and it returns a Boolean telling you that the specific conversion implementation is applicable between these, from this source to this destination. As you remember, this is a directed graph. So, if a specific conversion, API conversion implementation is applicable from this source to destination object, then this returns true as it returns false, right? The registry contains these, conversion implementations. And then, when a conversion request arrives, the registry checks which ones are applicable, and it applies them in a chain. So this is the overview of the API conversion registry that I'm talking about. We have some specific interfaces here, like the paved conversion and managed conversion. So the paved conversion runs on unstructured objects. It's very flexible and powerful. You can convert any types of objects, but when you are writing a paved conversion, there's no type safety. And if you prefer to have type safety, we also have this managed conversion flavor, which, works on resource.managed, objects so that, you can implement your, conversion, API conversion function in a type safe manner. So the managed conversion has a further prioritized flavor, which runs before all the other conversions. Next slide, please. So here you are looking at, a dynamic, chain of conversions that we apply. This is just an example. It doesn't mean that we apply this exact same pipeline for all version pairs of a managed resource. So this is just an example. In this example, we are starting with the V1 Beta 1, version, and in order to convert this V1 Beta 1 version to V1 Beta 2, we first run an identity conversion, and then, in the specific example, we have a singleton list converter, and then, let's assume we have a field renaming, and that's handled by renaming converter, and let's again assume we have a pipe conversion needed in order to be able to convert from V1 Beta 1 to V1 Beta 2. That one is invoked. And at the end of the day, what you get out of this pipeline is the V1 Beta 2 representation of the underlying managed resource. So the important thing to understand here is these are all composable building blocks for us to build these, dynamic API conversion pipelines for specific version pairs. And this is for each version pair, this is configured by the provider as we introduce new versions. Next slide, please. So, as I mentioned, prioritize manage conversions run first. And, you know, this is, for example, the identity conversion that I talked about, and we will also talk about it later, is a prioritized one. And then we pair the object and we run a sequence of paired conversions using the same pairs representation. And after all the paired conversions are run, we unpair it, and then we run the list of managed conversions in the order they are registered with the API conversion register. Next slide, please. So now we will look into what converter implementations we already have in Object. So we will start by looking at the identity conversion, then we'll talk about the singleton list converter, then field type converter, field profile. And we also have something called newly introduced field converters. We will introduce these building blocks out of which we build these API conversion pipelines. Next slide, please. So the identity conversion is the most basic one. And this handles, this is also the first, conversion implementation that we introduced. This is basically responsible for, converting, let's assume you are converting from V1 beta 1 to V1 beta 2. Most of the fields are unchanged, right? They are exactly at the same path with no type changes, etc. So this one is the first one that runs in the pipeline. It's a prioritized managed resource conversion, and it's responsible, and it's defined between all versions. So for a given object, whatever version pair you are converting between, this one kicks in. It's defined between all version pairs, and it copies identical paths with identical types. So this is the most simple one. And then this is very specific to object, right? So due to HCI, Terraform has what we call a singleton list, meaning that lists of at most one object, and they're not good for Crossplane, Kubernetes resource model. The main motivation we had to introduce the singleton list conversion is basically due to server-side apply. In order to be able to utilize, server-side apply without, list configurations, list merge configurations, we had to convert these singleton lists into embedded objects. And this API conversion is basically responsible for doing this. So in the example that you see on this slide, in version V1 beta 1, we have an alias as a singleton list. Remember that you cannot have two elements in this list. It's a constraint coming from the Terraform schema. And in V1 beta 3 version of this object, we have generated it as an embedded object, which better suits the Kubernetes resource model. And this singleton list to embedded object conversion, is registered in two ways. So when converting from V1 beta 1 to V1 beta 2, a conversion function named to embedded object is registered, and for the reverse direction, we have the singleton list, which does the conversion between the embedded object and the singleton list. Next slide, please. Yeah, so again, I can pass to you. Yeah.
Thank
So
you.
hopefully I didn't take too much time.
No, thank you, Alper. So yeah, let me also continue from here. So as we mentioned, there are a few more other converter types. This one is about the newly introduced field convergence. So let's hear the V1 beta 1 version and the V1 beta 2. And in our new version, we are adding a new field, retention, to the schema. And this is not actually in the V1 beta 1 version. So this is actually introducing a problem to resolve to here, not without losing the data, converting these actually versions to each other. So here, without any specific conversions, when we convert to V1 beta 1, this V1 beta 2 version, we are losing this retention. So we are using actually a method to writing annotation, these newly introduced fields for the previous version. And these are storing in the annotations because they are not in the schema itself. So, and again, converting to back V1 beta 2 when needed, we are reading from the annotation with the key, with the fields key, and then writing to the V1 beta 2 schema because it's already in there. So for this also, there's two directions similar to the singleton is conversion, from annotation and to annotation. The from annotation is into the way to new one, and the to annotation is the older one. So this is for the lossless conversion for the newly introduced fields. So the another type of conversion is the field renaming. So this is also a very common case for the schema change, especially it's let's say for specific namings are changing to new versions. Let's say the old one is name and the new one is the DB name. These type of sub changes, not semantic ones, but better qualified APIs. So here we are also have some special conversions. It's again like some new field renaming conversions with this the old key and the new key, and older to newer and the newer to older again. So the idea is here just handling them with a special converter, not writing one by one for each resources changes. And the primitive type change is still a very common one. We are also handling some type change for the GCP major version, for example. And here the idea is, let's say a field from float or number to string. Here we are trying to handle with this specific conversion. Again, versions and fields and also type of the primitive type change is declared here, like this into string, string and any actually change. Just please keep in mind is here is the conversions are not capturing all of these types. It's like for into string, float to string, and bool to string, and another direction from the string to another one. So this is a bit scoped, but as you imagine that handling the all of some maybe complex type is not possible. So this is for the primitive types especially. So we walk through with this 5 custom converters, specific converters, but also we may need some custom API converters when we can't handle the API change with these common converters. So for this one, we have some, custom converters. This is, as Alper mentioned, that we are mainly using the managed conversion, the type conversion here as an interface, because we are working on top of the resources customly. Let's say it's a real example from AWS set of scaling groups. This is actually changing from a map to a structured actually a struct type in the new API. So with these type of situations, we have a door to pass and writing the custom API converters to handle this type of changes, because we don't have to every time generalize the semantic change here. So here we are still to some custom API converters. So yeah, we may have some breaking change as we mentioned, but Also, we have some toolings to catch them on the build time. So we are using some schema diff tools to handle them. These are mainly actually getting the schemas, the CRDs, and checking the diffs between the versions in the same CRD, and actually give an output as a JSON format to process in the registering this conversion. So this is also an important point, is this we have a registration, auto registration for the conversions in the object. It's also a new feature. So the idea is that give the CRDs to tool, it will produce as JSON and auto registers the converters from this JSON. So this is the automation part. All of this common used conversion. This is the flow, that's what I mentioned. So this is, as I mentioned, just for the automation side of this specific converters. And also a trust point is, of course, the testing. As you know, validation is important. What can we know? We are not breaking anything. How can we know we don't have any issue in this pipeline? So Erhan from our team, he's also worked on this, adding the round trip unit test for the conversion side. The idea is, creating a spoke object, converting this to hub, and then convert back to spoke and check the first and latest spoke is, same with each other. This is the actually round trip unit testing for the object, and in our big three providers that actually serve the multi-version CRDs, it's running now, and it's increasing our confidence level to our framework. Because, in the generated APIs, it's every time not possible to review each, maybe the auto-registered conversions, or maybe in the runtime testing may not be feasible for all resources, but this unit tests really increase our confidence level. So the last topic is the API lifecycle policy that we introduced lastly. Here we have some actually special concepts. Handling this API version change. What we need this, because conversions are cool. We are handling this as Alper and me mainly actually mentioned. But apart from that, if you are releasing API versions, especially for the generated APIs, the API version life cycles are also another problem apart from the conversion. So you need to also handle this with a mechanism, and we have introduced this API lifecycle policy in the object side. This is in the object repository, by the way. Declared in there is an policy document. So the idea is that here, having some specific versions to safely deprecate, safely delete, and providing a safe downgrade and upgrade paths for the users. Here is the main motivation to introduce into the API lifecycle. So, because let's say we have a bridge phase for our lifecycle, as you see the previous version. Why we need to do this? Because let's say in your the v1.1.0, you are introducing in your first version, the 1.00, you are introducing a new version, let's say. And if you suddenly actually increase your storage version, or also the latest newly introduced API version, then the downgrade path is broken, because the storage version change is also a contract change for the users and clients. And when you try to downgrade without any reason, let's say you have a fatal issue in the next version, and at that point, your all resources in the V1 beta 2, let's say on the latest storage version, but the older version, the previous version, doesn't know the new API version. So we just introduce a bridge phase. This is the idea, is not promote this version to the storage one when you introduce firstly. This is the important policy for us to give a safe, still providing a safe downgrade paths, and also having a time to people also in their side for the deprecation and the removal processes. So this is mainly the idea. I will not deep dive too much, but I just wanted to capture here, apart from the conversions itself, managing the API version lifecycle is another point. This is also capturing what I mentioned in the previous one, and also says that if you are following this type of policy, you're not allowed to, arbitrary actually upgrades and downgrades. You need to maybe follow some upgrade path and downgrade path one by one. Because when you want to directly bump or downgrade, then at this point, some actually, as I mentioned, let's say the older providers doesn't know the new versions, and you can actually see some issues, these downgrades and upgrade paths. So the last slide is the general overview. Hub and spoke is just the starting point of the Kubernetes conversion, not the real solution. The real solution is composing this all, actually making the composable of this framework for the converters, finding the common cases, making the automations, and having this type of framework system. And of course, the actually latest one is as I mentioned, the validation phase. After all of this framework setup and all of this automation, still you need a real confidence, because API version management is important, because it's possibly relate to some, if you have wrong parts, you may actually cause some data loss. So this is not actually wanted stuff. So the validation is the important portion of the work. So yeah, thank you. It was just the final. We are on time, I think so. Yeah, thank you, Jared, by the way.
Yeah, Sergen and Alper, this is incredible work. Like, I kind of wish that I had seen some of these concepts a couple of years ago, especially when I was started exploring like the V2 implementation of namespace resources and provider AWS when we're very early prototyping of that. And I was like, hub spoke, what's a spoke hub? I had no idea what was going on. So I wish I knew that stuff then, but this is super useful for provider authors, and when we don't control the schemas underneath, the Terraform providers, if they choose to make a breaking change, well, we got to absorb that somehow. And this framework here is a fantastic way to, kind of bring some, tame all that craziness, right? So this is awesome. I did not a couple minutes ago, but now I have a hard stop that I have to get to. So Adam, Alper, and I think Sergen actually has a hard stop too. So Alper and Adam, I've made you all co-hosts. So if there's more questions and discussion here, you all can keep driving that. But thank you so much, Alper and Sergen, for coming, and thanks everybody else for coming today too. And I will take off.
Thank you. Yeah, so I see a question from Jonathan. Is there a way to make multi-minor version jumps supportable by reading the cloud resource itself, observed by extending to the top at the desired version? So we are talking about multiple minor version jumps of the Terraform provider, Jonathan?
So I think 2 or 3 slides from the end there, you said that you have to go from 1.0 to 1.1 to 1.2 and hit every version in between.
Provider version. So, yeah. So the thing here is why let me explain why we put that constraint. So when we are going from these versions, we will be changing the storage version, right? So let's say we have V1 Beta 1 as the storage version initially, and then we introduce V1 Beta 2. At some point in time, we will mark V1 Beta 2 as a storage version, and V1 Beta 1 is deprecated and is no longer the storage version, right? And then at some point in time, with a new version of the provider, we will remove V1 Beta 1 after migrating, making sure that all the custom resources have been migrated away from V1 Beta 1. No one uses that. We can remove that. So once we start implementing that policy, it becomes dangerous to jump versions. That's why in the policy that we put, we will be recommending these sequential updates. So for a specific provider, it might be possible to jump versions. It depends on what we have removed and, what stays. But the general guideline will be to do this, in a sequential manner. So it's not a hard requirement. It depends on the path that we implemented for a specific provider and what changes between the provider's versions. But if you want to save yourself from trouble, it will be the recommended approach.
Yeah, I understand why you would have implemented it that way and why you would add that constraint, just from the perspective like the Kubernetes object model, right? The reason that I asked the question is because at the end of the day, the representation of the object in Crossplane is a layer of abstraction over the representation in the cloud. And so if we're using kind of the hub inside of the provider object model as the source of truth, and the reason that those upgrades are dangerous is because we might have changes in that source of truth that aren't representable, like that kind of don't converge in the middle between those versions, where there's like some required upgrade or something. I was wondering if, to kind of restate the question, if it's possible to derive that information from the object itself in the cloud to kind of reconstitute the hub version at the tip version of what we've already stored it, say in Amazon.
Yeah, so let's assume we have 3 versions of a provider, V1, V2, and V3, right? And at version V2, we remove a specific version, let's say V1 Beta 1 of a CRD. When you try to upgrade from V1 directly to V3, you are basically deleting a version, right? Mm-hmm. The CRD loses the version. Maybe there are still objects in etcd using V1 Beta 1, and this is forbidden. You cannot do this, right? So, how can we use the cloud representation as a source of truth? So this is not related to that one, but it's related to the mechanics that are implemented in the provider. I don't know if I understood your question correctly, but it's not driven by changes in the cloud resources representation. This is driven by changes in the provider itself. Specific API additions, removals, what gets marked as the storage version and what's, removed, etc. So, I cannot see how we can use the cloud representation as a definite source to prevent these problems. But maybe I'm missing something.
No, and this is partly me being naive about the solution, right? But I've done a lot of recently onboarding to Crossplane, right? And so one of the kind of main mechanisms that you use to onboard stuff in Crossplane is just like setting the management policy to observe. You go and watch the thing as it exists in the cloud, and then you use that to render it into a resource at the tip version that's provided by that provider. And so there's this sort of notion that's baked into my brain about like forgetting and then re-importing. And so I wonder if there's some like automation around, like if people did need to do a big version upgrade for whatever reason, some notion of having the Crossplane provider basically forget about that resource and then re-import it at the tip version instead of having to go through all of the intervening versions.
Okay, I see. I mean, let's say, when you say forget about it, maybe delete the resource and re-import at the latest shape, right? So if that's something that we are going to apply, it's definitely possible. But it's not continuous, right? You are deleting your managed resource, you are installing, you are doing the jump, and then with the latest version, you are re-importing it, right? So as an observer on the resource, for example. Yeah, so I now see what you're saying. That's that's something possible. But the assumption here is with sequential updates, there is continuity in the object's existence. Thank
Thanks.
you for the question. Thank you.
If there's no other questions, I think there's nothing else in the agenda. So thanks everyone for joining. Anything else before we go? I didn't have anything else. All right. Thanks everyone. See you next month.
Thank you.
Right.